So now let's start for the presentation of the next unit, which you will find on the website as unit 3.2 in the common session, and which is food packaging and shelf life. And this is quite important field because we have a lot of demand coming from the industry, for example, for student training period, for projects related to how may I determine the shelf life of my food. And of course, it's related to the packaging because most of the food we are buying are packed. In this unit, what you will find are 4 different subsections. The first one is shelf life definition. So how could I define shelf life? We will see together that it's not so easy. The second one is factors affecting shelf life. And you, as food technologists, you probably may know this quite well, so I will go rather fast on that point. Then how to study the shelf life, and we'll especially talk together about the accelerated shelf life testing. So how can I increase and save time in order to estimate the shelf life of my food? And then we'll go a little bit in how to predict the shelf life, so modeling aspects. So first of all, let's start with the shelf life definition. And shelf life means this is something related to time. And within this time, you have the manufacturing plant, the time in between with transportation, then at the retailer place, and then at home and before the consumption of your food. And the question is, up to which time could I consume my food? It's also related to food quality, so a very basic definition of food quality would be this one. Food quality could be defined as the combination of attributes or characteristics of a food product that have significance in determining the degree of acceptability of the product for consumers. So behind that definition, what's important is that food quality means also degree of acceptability. And this is something not so easy to define, so we'll come back on that after. Of course, as a food technologist, you also know that you have many different phenomena that have an impact on the stability. And this is what you are studying, for example, in food science and technology. So, what are the relationship between food quality and shelf life? That means for the shelf life, you will turn from something that you will consider acceptable down to something that will turn to be unacceptable. Okay, when I will say that, I will say almost nothing, and except that there is a time to determine in between. So let's see what could be behind the shelf life. So shelf life definition could mean something different depending on who you are. For example, you will see very well what means shelf life as a consumer, but it could mean something else if you are a retailer. Could also mean something else if you are working in transportation of the food. And it will mean also something else for the product manager and developer. We will take into account all of these different aspects up to the consumer level. So depending on who you are and where you are working, the shelf life could mean something a little bit different. If we go a little bit further again, it could also mean something different. If you consider socioeconomics aspects, that means these criteria could be subjective and changing, but it's important, as we said, for the retailer, on the transport, these aspects are very, very important. It's also important for the food industry that will put on the market some product with a given shelf life. It's all the most important now when you are thinking about food waste too. And on the other side, you have also scientific aspects that are objective and not changing. And these are on this one that we'll see a little bit aspects together this afternoon. How could we put some scientific criteria behind the shelf life in order to do some prediction for the shelf life of your food? So still in the definition of the shelf life, we could see also where the definition of the shelf life is coming from. And for that, I just selected on this slide 3 definitions. One dates back already from the 70s, so it's not a new thing about shelf life, but it's still a very active and intense question that we have. And it has been first defined by the Institute of Food Technologies in US. And they define, as you can read here, shelf life as a period between manufacture and the retail purchase of a food product, during which time of the product is in state of satisfactory quality in terms of nutritional value, taste, texture, and appearance. So that was one of the first definitions of the shelf life. It is said satisfactory quality, so it could be under debate. And what is considered in this first definition are only nutritional aspects, taste, texture, appearance, and what we could define as sensory aspects also. Later, we can find also another definition from UK, this one, and I will not read everything, but what we can see which is added in this definition is a macrobiological aspect, and it's a key criterion in the definition of the shelf life, because we can say that this is one of the most important, for safety reason, aspects of the definition of the shelf life. The other one, of course, would be oxidation and chemical evolution of the product. So microbiological evolution or chemical evolution, both of these criteria are very important for defining the shelf life. And more recently, in the European regulation, we had this morning a talk about regulation, and there is also something related to shelf life in this regulation, which define the use by date or the minimum durability date as it changed recently in the regulation. So what you can see in this regulation means also what you could label on your food product. And in Europe, within the frame of this regulation, you can find three main categories of food. You will have an example of them in the right side of the slide. And you can label different things according to the shelf life of these food products. So for products that have a short shelf life, let's say this is below 3 months, you can mention only the day and the months. For products for which the shelf life is between 3 to 10 months, so medium shelf life, we would say, in that case, you can label months and year. And for shelf life over 18 months, and this is the case, for example, of the bottle of water, in that case, you can mention the year. What's also important to have in mind is the date of minimum durability of food. And this means the date until which the food retains its specific properties when properly stored. And this is an important thing, because the environmental conditions to which the product will be submitted will obviously affect the shelf life. And the label you can put on your food, according to the same regulation, is either best before or best before end, and that means this is an acceptable quality limit. And this also means for the consumer that you can eat the product even a little bit after this time. Opposite to that, you can have the use by, and in that case, this clearly means this is for highly perishable products, and you cannot go above that date. And this is an important limit between different kinds of products for which the shelf life could a little bit extended. You are above some quality level that will not have safety impact. So another definition means we have something to better understand between the acceptability limit and the safety limit. And this is what the regulation is saying to us also. So for shelf life, that means this is only a dissatisfaction risk. The quality parameters are changing, but there is no safety issues. And above that time, you could have the safe life, and in that case, it's important to have in mind that there is a health risk for the consumer, so you cannot go above that time in that case. So just pay attention to shelf life versus safe life in that case. Now, having a look on the rate of deterioration, and for those of you who like chemical kinetics, of course, this is related to chemical kinetics, and you can really go further in better understanding what are the degradation rates behind. And if we simply look at a quality factor, so on the y-axis there over the storage time in x-axis. You can see different times, so the time of packing, and there will be a degradation of the quality. It's very rare to have an increase of the quality. You could have this for a very few products, some fruit, and in the region we are living, of course, wine. And wine, the quality is expected to increase up to an optimum consumption. And in that case, this is always under debate, what is the optimum. But you could have, in that case, a quality that could increase at first. But in most of the cases, you will have a decrease of the quality over time. So, and this rate of decrease will depend on the environmental condition the product will encounter over the time. So in that case, in this example, it's a quite fast decrease at first. Then at the grocery store, we could expect that the environmental condition will not change too much. And at the consumer level, things happen that we do not know. And sometimes it's well stored, sometimes not. And so the rate of decrease, in that case, depends on which environmental condition will be there. And what's important for defining the shelf life is that you will fix an acceptability limit on this quality level, which will define when the shelf life will be reached. Still with the definition, it's important also to have in mind two different definitions about shelf life. The first one will be called primary shelf life, and we'll define it for products that will not be opened. And that's important. So still the quality decrease over time. You will have an acceptability limit that will define your shelf life. And with the failure time, that means the food will be no longer acceptable for the acceptability limit you fixed. This means the product is still packed, and you can have a good idea about this decrease of quality in the product still packed. Opposite to that, you can have also the secondary shelf life. And in that case, that means you will open the pack. And for some product at home, just think about dry products. You will open the pack, then you will put it back, you will reopen, but the pack has been already opened. So that means the quality decrease, the quality deterioration will occur much faster. And that's also something important to have in mind and to consider this secondary shelf life. So in blue line here, for example, you have the primary shelf life, the things we just saw previously. And up to that point, when you open the pack, this means you will have another rate of decrease of the quality. And this will define the secondary shelf life. And now for some food product, you will find a primary shelf life that is indicated on the packaging, but also a secondary shelf life. That means what's the time for you as a consumer you will have to eat your product. And this is quite important also for food industry now to pay attention to this secondary shelf life, because this is an additional information you could add on your packaging for the consumer to indicate to him, okay, when you will open the pack, then the deterioration rate will change and you will change also the shelf life. And this is quite important for many products. And also for products you might store in the fridge, like let's take the example of mustard. We are in Dijon today, so this is also a good example. You will open it, you will put it in another temperature range, and then you will put it back in the fridge. It will be open, so it's quite interesting for the consumer to have also an information about the secondary shelf life. Maybe mustard could be difficult to estimate the secondary shelf life because it depends a lot on the condition the product will encounter in the condition of use. But let's think about, here this is an example of cosmetics products. For cosmetic products, this is a particular case also. It's not food, but it's rather similar. And in some cases, with a project with students, we have often the opportunity also to work with cosmetic products. And for the formulation for this kind of products, this is stored at ambient temperature, and the shelf life is up to 3 years. So it's very long shelf life. And once it's open, so that means they already define in that field what they call period after opening. what I defined just before as secondary shelf life for food, it's already there for cosmetic products, and it is called period after opening. And that means the consumer have this information, and of course the shelf life will change once it's opened. You can still store at ambient temperature, and in that case, the period after opening is, in most of the cases, about 12 months for cosmetic products. So, which is incredibly high shelf life when you compare to the food products. As an example for food, to come back in food science and technology, let's consider coffee. And coffee, grounded coffee, which is packed in a specific packaging. Usually it's under vacuum. It's with multi-layer packaging, mostly to preserve from aroma, from light. And the shelf life is quite long. You can see it will be between 8 to 18 months when it's stored at 25 degrees. And the secondary shelf life will decrease dramatically. It's only 20 to 30 days at 25 degrees when you open the pack. So this is very interesting information to provide to the consumer, because the shelf life to consider is absolutely not the same when the pack is open. And now things are also changing for that. It's not yet in the regulation as for cosmetics, but some industry are already supplying this information to the consumer. So that was to give to you some basic definitions about shelf life, but it's still interesting to have this clearly in mind when we are talking about shelf life. Now for the next thing, it will be factors affecting shelf life. But for this subsection, I will not spend much time because it's already there in other units, and I will not have time. It's just to show you a global overview about this unit today and not to go into too much detail. So even for the other subsection, I only selected some slides to present to you and to make you want to come to visit the website and to pick up some more information once you will visit it. So for factors affecting shelf life, I will briefly sum it up. We have to consider for shelf life of a food product, of course, the food. And most of you, as food technologists, you know very well the food and the properties and how the food will evolve as a function of different conditions. These different conditions are the environmental conditions. And you will have to define what will be the environmental condition the product will encounter during the shelf life. And the other part is packaging. And this is also something very interesting to consider because, as I said when I started, almost all products are packed, and this will change a lot the shelf life of the food product. And having a good knowledge about what was presented in the first presentation of this morning about mass transfer, and then you could use this information about permeability. That means if you are able to correctly read a datasheet of a packaging supplier, in that case you can use this information and you will be able to calculate the shelf life of a food. So for food deterioration, I will shift this slide and I will spend a little bit more time on others. So you know already that you have some perishable foods. That means very short shelf life, or minimally processed food. You will have some semi-perishable food. That means short to medium shelf life when you have natural inhibitors or when you have meat preservation treatments. And you will have medium to long shelf life food. And in that case, that could be unprocessed food because, for example, they are very dry. You could have also sterilized food. You could have foods that contain preservatives, like soft drinks. They are quite stable over a very long period of time. Foods formulated as dry mixes, very stable also. And food processed to reduce their water content. And these are very different situations, and that means for every food, you have to ask yourself some question about what are the most important criteria that will define the acceptability limit you will fix. And once you know that, after you can study the evolution over time. For environmental factors, this is also something very important to define and very important to pay attention to when you will send your product. So you know that most of the product will be transported, and some of them will be transported over all over the world, we could say. So that means, for example, when they are shipped on boats, you could have conditions of temperature that will be close to 50 degrees on the outside. And so that means 50 degrees is not an accelerated shelf life testing in that case. It is really the temperature that the product will have to face during the transport. Light condition is also very important. A good example is glass, so the bottle of glass. And let's consider, for example, a champagne. And champagne, when it's stored in a white glass bottle, you could have the effect of glass, and that means you could have photo-oxidation in that case. And this is something also very important, because in the shelf life testing, you could play with temperature, but sometimes you could also play with light. And especially in the field of beverages, soft drinks, other alcoholic beverages, as the example I just cited, in that case you could also play with light as an accelerating factor. Relative humidity, of course, is highly important, especially if you consider dry foods. So this was the last previous category I just mentioned, and in that case you will have to pay attention to water, and especially to avoid caking for products that you might think at first that they are very, very stable. And the temperature, will come back a little bit on that after. So now we are coming to the packaging issue. And as food technologists, some of you know quite well the packaging, some of you not yet. And this is also important to consider and to have good knowledge about the packaging. And this is why we would like also to share to you these fitness training courses that are freely available, and to increase also the knowledge about food packaging. And this is good knowledge that you can extract and implement after in your shelf life estimation. So in most of the cases, you will consider what will be the mechanical stresses that the packaging will have to face during the shelf life, the chemical reaction you could have, the microbiological reactions, and the physical stresses. And the choice of the packaging material is also a key issue in determining the shelf life. When I started as a food engineer in the industry, I was not aware about food packaging, and it was quite difficult to discuss also with supplier. And it's an important part of your job also to well select the good packaging for the food. And that means you have to adjust the food packaging properties to the food properties. So really good for food scientists to be able to make the link between the packaging and the food. And now, as we'll see also tomorrow with the presentation dedicated especially to environmental issues about food packaging, you have also some new materials coming to the markets as bioplastics, or let's say biodegradable, which will be even better in this category. When you consider biodegradable materials, we have the example this morning about the regulation and how to determine their properties in contact with food simulants. This is also the same thing when you consider them for shelf life study. And with biodegradable materials, you can wonder about the shelf life of the food they will pack, but you can wonder also about the shelf life of the packaging itself. And this will maybe define another shelf life issue. That means when you are using biodegradable materials, you can also ask yourself about the evolution of the properties, not only of the food, but also of the packaging. And this is a key issue when you will select this kind of packaging too. Now, the third part I would like to present to you is how to study the shelf life. And to study the shelf life, we'll talk about accelerated shelf life testings. Just to briefly sum up, what will happen for food in a package? You will have transfer, and that's why we started today with mass transfer and permeability. That means all of the materials are permeable, and this is also what Professor Langowski told us yesterday. Even when you consider a bottle, you have to consider in that case a cork stopper. And you can have permeability from this side, you can have permeability from this side. You will have exchanges also between the gas that will enter in the headspace and the food. You will have reaction on the surface of the food. You could have reaction in the inside also, depending on the rate and the respective rate of the diffusions for the packaging, the diffusion in the food, and of course this is related also to the solubility aspects. What you will study, if you want to study the quality changes of a food over time, we can have some stability studies. That means you will follow the evolution of the quality over time, and you will have a rate of quality decay. And when you will do a shelf life study, what you will have to define is an acceptability limit. And this will be the first point you will have to think about, and this is the most important one. It's not as easy as you might think to define what will be the acceptability limit. If you take an example of a food and just think about the food in your mind, and what will be the acceptability limit for the food, it could be many, many different things. But you have to select what will be the most important one. And this is the one you will follow in that case, and you will define what will be the acceptability level. And this will be really a key role you will have in the food industry to define what is this acceptability limit in order to do a good shelf life study of your food. We could have some errors that may come from a wrong definition of the acceptability limit. You might think about a microbiological issue, but it's not. It could be a chemical issue. And so this is something really important to define at first. And after, the global scheme of the shelf life assessment process is this one. So the primary step, as I insisted on that, is the identification of the critical event and the good descriptor that will be really relevant for the acceptability limit. And this is a key point to my mind. And then you will do your testing. That means you will choose either the real condition to which the food will be exposed to, or you can choose accelerated condition, of course, if you want to save time. And in most of the cases, you will choose this option. And after, that means you will have either a shelf life estimation or shelf life prediction, and you can use modeling if you want to save time too. So modeling is here to help you to save time. To go a little bit further for accelerated shelf life testing, most of the people will use temperature as an accelerating factor. This has been also told this morning for other aspects. And you can play with the temperature and you will increase the rate of the reaction. That works also for microbiology, not to the same extent, but that works too. And in that case, you will use the Arrhenius equation, and you can extrapolate to normal condition of temperature. Normal means, could mean 4 degrees, could mean ambient temperature. It depends, of course, on the food product. Arrhenius law, I will shift this, but this means this is the law that most of the people are using when dealing with temperature effect. And I will prefer to discuss with you about the challenges you might face with accelerated shelf life testing. So what could be the main limitation when you will perform such accelerated shelf life testing? And this is something very also important to pay attention to. So what we already said is it could be a wrong choice of the limiting acceptability factor. This is why I really say that this point is a very important point to well define at first in any kind of accelerated shelf life testing test. After, you can have errors in analytical and sensory procedure. Other thing quite important to know is phase changes in food. That means when you will change the temperature, you could also change the physical structure of your food. Like, for example, you could have melting, you could have crystallization, you could have the glass transition that is in between of your temperature range you will explore. So that means you can change the properties of your food when you will change the temperature for accelerating things. You could have also some concentration of reactants on freezing, and that means you will have different reaction rates because the concentration are not the same initially. and it was not the same as what you thought at first. You could have different reactions that may predominate at higher than lower temperature, and something that you thought linear at first will not be because you will change the reaction. The water activity of dry foods increases with temperature, giving an increase in reaction rate, so that could be also another limitation that you might encounter. Another important thing is the solubility of gases, and let's consider, for example, oxygen. That means the solubility will decrease when the temperature will increase. So you will save time, but you will decrease the oxygen concentration level when you will increase the temperature. So that might be a different situation from that at an ambient temperature, for example. And as we saw also, the permeability of plastic packaging will increase with the temperature. So these are limitations that you might see in performing accelerated shelf life testing. And so that means you really have to think about all of these limitations. So the definition, the good definition of the acceptability limit factor, and also to consider all of these limitations that you might have when performing such ASTL experiments. And now for the last part, I will go quite fast also within these next slides, because we are already entering the last 5 or 10 minutes for this talk. But it's to give you the tools also, to show you the tools about how to predict the shelf life of the food, and to give you some basic information about modeling, not very complicated modeling, but some simple models that can be very useful in the prediction of the shelf life of a food. So I sum up here different situations. And the first one for the shelf life, that could be based on the chemical or microbiological degradation. That means you can simply consider the chemical kinetics for the deterioration of a component of the food and to follow it. Or you can follow the microbial growth on the food. You will not consider the packaging in that case, of course. You could have another situation, which is the shelf life based on moisture or oxygen transfer through the packaging material, which means that for a given case, you can consider only the packaging and not the food in that situation. These two first situations are quite easy because you are not combining both informations. The third one is that you can couple moisture sorption by the food and moisture transfer through the packaging. So it's quite interesting because you will have both information that you will combine together. And you could do the same with oxygen. We'll see that it's a little bit more complicated. And the last case, but I will not go into it, is that we can consider what we saw this morning and what was presented about migration aspect. And you could imagine also a shelf life which will be based on toxicological concerns. So I will briefly detail the different cases, and after it's up to you to go to the website and to visit and to know a little bit more. Or if you need one day or another this kind of information, you can have access to this training course, and you can gain some much more information on the website. So the first one, as I started the talk this afternoon, is chemical kinetics could be quite important to know when you are dealing with the food shelf life. And clearly, it's important to know. And that means, for example, this is a chemical kinetics like a vitamin loss. And in that case, you will follow the degradation. And you have to know a little bit about the order of reaction, the rate of reaction. And in that case, you can use very simple models from chemical kinetics in order to model what will happen to your food. Modeling doesn't mean you will not do experiments. You must do experiments, but after you can save time not doing all of the experiments, and that's quite interesting for that. The same thing will apply for microbiological degradation, and with a classical growth rate that is shown on that slide. And in that case, you have also something related to time that you can consider as the shelf life in your shelf life of your food based on the microbiological growth on your food. And that's also quite interesting. You can take the information you know elsewhere from other classes or from your background. Then, dealing with the properties of the food packaging, in that case, you could estimate the shelf life based on the barrier properties of the packaging. So this morning you had a talk about the mass transfer properties. That means the barrier effect due to the packaging, called also permeability or permeance or transfer rate, depending on the supplier and on the datasheet you will have in your mind, in your end. And in that case, you will have to define the maximum moisture or oxygen allowable by the food, and you will compare that to the barrier properties of the packaging. So putting that in equation, that means you will use the permeability, you will use the differential in partial pressure of oxygen or water vapor, the surface area of your food, the thickness of your packaging, and you can determine a time which is the shelf life of your food. So basically what you will have to put in that model is just a maximum allowable quantity of oxygen or water. The next model is shelf life based on both moisture absorption and moisture transfer by the food product. In that case, you will consider both things. You will consider on one side the sorption isotherm, that means the quantity of water that will be adsorbed or desorbed by your food, and on the other side, the quantity of water that will come in contact with the food, or in the other way around, that will escape from the packaging. Could work both way around. I will go rather fast, and that means you will have to consider the moisture sorption isotherm. That means the water quantity, water content in your food according to the relative humidity of storage or water activity of your food. And you will define the initial water content, the critical water content. So that means this is related to the acceptability limit factor we discussed just before. So that could mean just a threshold of water for microbiological growth. That could mean a threshold of water for quality change, such as texture, for example, different things. It's up to you to define this value. And the last value is, if there is no packaging, this will be the equilibrium value of the food in the environment you will put it. There are some assumptions of the models. I will shift that slide, and you will come to an equation you will probably dislike at first, which is this one. But actually, there are many parameters in it that are constants. And so it's quite easy. I will not detail too much for today, but basically what I will only say is that this one is a constant, this one is a constant, this one too. This one is a permeability. So you will find it on the technical data sheet. This one is the surface area of your packaging. You are able to calculate quite easily. This one is the saturated vapor pressure of water at the temperature of storage. You will find it on tables. This is the thickness of the packaging. You will have it on the technical data sheet, or you will measure it. This is the slope of the sorption isotherm. You have to linearize on the one of the previous slide. And this is a dry mass of your food product in the packaging. So that means only constant in that equation. And from that, you can calculate the shelf life. It's quite interesting to have in mind that this shelf life is based not only on the property of your food, but also on the property of your packaging. So this is what I said first when you are combining these two parameters together. And after, you can do the same thing with oxygen, but I will not detail that. And it's much more complicated with oxygen, because you will have, this is the same concept, you will have the oxygen entering in contact with the product, your packaging in the barrier to that, and then you will have reaction of oxygen, so oxidation of your food product. And you will have to combine both permeation equation, mass transfer equation, and then reactivity with your food product. And you can develop many models. You can see some of them in the literature. It's not as easy as the previous ones I showed to you. And the last case, as I said, could be based also on toxicological concerns. And you can estimate also with the model that were presented from this morning some shelf life based on the migration of constituents from the packaging. So to sum up about shelf life determination of the food concerning food that are packed, it's really important to consider the shelf life when you have to determine the sell-by date or the use-by date. It's important also for people that are playing with the formulation of food or processing condition. So you will change the properties of your food, and so you will change your shelf life, and you will have to adapt maybe the packaging. It's important when you are testing new products and new food packaging, and in it you have in this training course you have the basic knowledge and the basic case studies in order to be able to have a good idea about what is shelf life, what is shelf life important for, and how to determine the shelf life with some basic model. And if you have to perform accelerated shelf life testing, what's really important to consider. And this is what I really would like to insist on with you today, as you saw. But it's really important for you to have this in mind when you are designing accelerated shelf life testing in order to predict what will be the shelf life of your food, including the packaging properties. So I thank you for your attention, and questions are welcome.